Let's look at first order differential equations where we use the integrating factor method. So some key notes are, when we have f of x times dy over dx plus f dash of x times y, then this can be written as the derivative with respect to x of f of x times y. And for a first order differential equation of the form dy over dx plus p of x times y equals q of x, the integrating factor, which we'll call if, is e to the power of the integral of p of x with respect to x, where p of x and q of x are some functions in terms of x. So the question says, solve the differential equation x cubed times dy over dx minus x squared times y equals 1 at x equals 1 and y equals 1. Now the first step is to rewrite this differential equation in the form dy over dx plus p of x times y equals q of x. And so in this case we can see that we have x cubed in front of dy over dx, so the first step is to divide both sides of the equation by x cubed. Now if we do that, the first term here has x cubed and that cancels when dividing by x cubed, so we end up with dy over dx. And now for the second term we have minus x squared times y, which when we divide by x cubed we end up with minus y over x, and then 1 divided by x cubed gives us 1 over x cubed. And now more explicitly we can rewrite this as dy over dx minus 1 over x times y equals to 1 over x cubed. Now if we compare this with dy over dx plus p of x times y equals q of x, then we see that p of x must equal to minus 1 over x, since that's the function being times with y, and then q of x is equal to 1 over x cubed. So we're now going to work out the integrating factor, which is e to the power of the integral of p of x integrated with respect to x, which in this question is equal to e to the integral of minus 1 over x integrated with respect to x. And now if we work this out, the integral of minus 1 over x is equal to minus ln x, and so we end up with e to the power of minus ln x. And now if we use the power law for logs, we can bring the minus 1 up to give us e to the power of ln of x to the power of minus 1. And so e and ln are inverses which cancel, and we're left with x to the power of minus 1, which is the same as 1 over x. And so our integrating factor is equal to 1 over x. Now to rewrite this differential equation in this format, we now multiply every single term by the integrating factor. And so this equation multiplied by the integrating factor gives us dy over dx times 1 over x, which is 1 over x times dy over dx. Then we have minus 1 over x times y times 1 over x, which gives us minus 1 over x squared times y, and then we also have 1 over x cubed times 1 over x, which is 1 over x to the power of 4. Now if we compare this equation with this format here, we can see that f of x is equal to 1 over x, and now if we differentiate this, f dash of x is equal to minus 1 over x squared, since 1 over x is equal to x to the power of minus 1. And if we differentiate x to the power of minus 1 with respect to x, then we times by the power and then take away 1 from the power, and so this becomes minus 1 over x squared. So the left hand side here can now be rewritten in this format, where we have the differential with respect to x of f of x, which in this case is 1 over x, multiplied by y, and this equals to the right hand side, which is 1 over x to the power of 4. Essentially, this is the product rule, and now we're rewriting the product rule in reverse. As if we were to differentiate this with respect to x, we would then use the product rule to produce this. And now we integrate both sides with respect to x. So we have the integral of the derivative with respect to x of 1 over x times y with respect to x equals to the integral of 1 over x to the power of 4 with respect to x. And so on the left hand side, the integral and the derivative with respect to x cancel, and so we're now left with 1 over x times y. And on the right hand side, to integrate 1 over x to the power of 4, we have the integral of 1 over x to the power of 4 with respect to x is equal to the integral of x to the power of minus 4 with respect to x, which when we integrate gives us, adding 1 to the power, x to the power of minus 3, and then dividing by this new power, we get minus a third as a coefficient, plus c, since the original equation is y being differentiated with respect to x. So the right hand side now becomes minus 1 over 3 x to the power of minus 3 plus c. Now if we use our boundary conditions x equals 1 and y equals 1 and substitute into this equation, we end up with 1 over 1 times 1 equals to minus a third, and now x is equal to 1 here, so 1 to the power of minus 3 is just 1, and then we have plus c. So this simplifies to 1 equals to minus a third plus c, and now if we add a third to both sides, we end up with 4 over 3 equals to c. And so therefore our equation now becomes 1 over x times y equals to minus a third x to the power of minus 3 plus 4 over 3. Now we can rewrite this equation as 1 over x times y equals to minus 1 over 3 times x to the power of 3 using index laws plus 4 over 3. And now if we multiply both sides by x now, on the left hand side 1 over x times x cancels, and so we're just left with y, and on the right hand side minus 1 over 3x cubed becomes minus 1 over 3x squared, since a single x cancels, and 4 over 3 times x gives us 4 over 3x. And so y equals minus 1 over 3x squared plus 4 over 3x is the particular solution to this differential equation at x equals 1 and y equals 1.